Hi, so I'm Ben Kehoe. I work at iRobot on cloud robotics. And I'm lucky today because I'm not relying on the Wi-Fi because I'm going to talk about stuff that doesn't yet exist. So I'm going to talk a bit about what's missing, what I see in the community. Yesterday, a colleague of mine talked about how we do operations at iRobot for our serverless infrastructure, supporting our connected robots. And today, I'm going to talk about sort of not just what we see at iRobot, but what I see in the community. People are finding pain points. So a little bit about me. I'm a cloud robotics research scientist at iRobot. And it's the combination of two buzzwords. But what it really means is using the internet to enable robots to do more and better things. And at iRobot, we're completely serverless, supporting our connected robots. And so that's a fun cloud robotics piece for me. So we, the people here, and us at iRobot, we've accomplished amazing things using serverless architectures. But there's still things we can't do, right? So we can do all these things. We can, at iRobot, we've built these things. Nordstrom is doing amazing things. Capital One, right? People are using the serverless framework. And we're doing all this stuff, but there's places we go and we're like, well, that's just not possible yet. Or it's too hard, or we're coming up with Rube Goldberg machines to get around it. And so I'm trying to address, what do we need and why do we need it? So I decided to start off with a bold statement that's going to offend a lot of people, but I don't really mean it. Node is the wrong runtime for serverless. But bear with me. So JavaScript design, right, is oriented around asynchronous invocation. And there's good reasons for that, right? It was originally built as, around the UI of the browser, and then it got server-side, and Node leverages that to achieve high concurrency, which is great on a web server, right? You can handle all these connections because you're doing it all asynchronously, so you're not using resources while you're waiting. But serverless functions, right, should almost always be single thread, single task, right? You want to do one thing, you want to do it well, and that should be, sort of imperative in some ways. Now, everybody's got an exception. Everyone's got a big fan out that they want to do all in parallel, or they're fanning in or something, right? That's always true, and for that, using some asynchronous primitives in your language is going to be really handy. But more fundamentally, what we want is that async design needs to move into the infrastructure, right? That we want the ability to have that, callbacks, sort of promises in some sense, move into the component graph rather than within our code. So the Serverless Manifesto, I'm not sure exactly, this may have come directly from Tim Wagner in the first Serverless Conf. I know it appeared there. But it goes through, it's a bit actually of a functions as a service manifesto rather than serverless more broadly. But right, you want functions as the unit of deployment and scaling. You want, that you're not dealing with VMs. You want it to be stateless in the function, that state to live elsewhere, whether it's in a database or a management layer like step functions or logic apps. You want it scaling per request. You don't want to pay for idle. You want to be fault tolerant so that your functions can get moved around and you don't care. And right, it's your own code, you're bringing it, and metrics and logging. But I want to add another piece to this, and this is the piece that I don't think we have yet, which is that we want architecture parity with existing microservice implementations on servers. Right? We want people who build microservices to have the ability to port what they've done and get all of these benefits without having to move to a new paradigm yet. And I would argue that, right, functions as a service just by itself is not microservices quite, right? Functions as a service are stateless, ish. There's things you can do. But is functions as a service plus a database a microservice? I'd say, maybe initially, right? But you start adding up, what are all the other pieces that I need? I need API gateway in front of it to provide that API. I want a key management service to handle my encryption. I want some stream processing or some queuing in there, right? All of these pieces, build up into what each little microservice is going to be. So the truth here in differentiating between functions as a service and serverless is that serverless microservices are functions as a service plus software as a service doing everything that's not your business logic. That's the ideal, right? And your business logic and your functions as a service, right? Ideally, the happy path is 10 lines of code and it's all SDK calls. And then, you've got 10 or 50x for the error handling that you're going to go through. And that tends to be, in some ways annoying. You're like, well, I wrote this thing, and it's like, okay, well, now I've got, a bunch more time to write all of the error cases I have to handle. But it's good because when you're building a serverless application, you're distributed first, which means you're handling those cases, which may be hidden from you if you're building on servers. Right? This is one of the benefits we get. So continuing on this, right, traditional architectures produce traditional microservices, just as a definition. And when you really go functions as a service native, you get these event-driven architectures. This is an image from Hello Retail from Nordstrom. And it may look very different, right? There's a lot of, let's have an event log, and we'll drive it off of that because that makes a lot of sense when Lambda can trigger off events. But at the same time, this means that you're going to end up with less clear boundaries. When you have a stream that goes between an ingestion service and some other service that's processing it, does the stream live in one service or the other? And where do the bindings live? Where do the permissions live around all of these? So it's not clear yet. This is very sort of paradigmatically different from these traditional microservices. And so you don't want people to have to change their mindset entirely just to get the benefits of serverless. We want the ability to replicate those traditional microservices to enable people to come sort of into the serverless world before they sort of really change everything and get how they can build these new architectures. So to me, the question is there enough of that software as a service infrastructure in the ecosystem of any given provider, whether it's on AWS or Azure or Google or some compendium of the smaller providers to build the microservices we want? And my answer is not yet. There are still pieces that we're missing, important pieces. And in this, I'm going to, we're at iRobot, we're on AWS, and so I'm going to use AWS as sort of the avatar for the other services, and I'll talk about where they differ. So one of the things we need for these traditional microservices is to have clear delineation between the services. There's an API surface, and you can update behind that surface where it's transparent to anybody that's using it. That's one of the ideal pieces. You want the ability to update the inter-service graph at runtime, right? That you're using a service and you want to swap it out for something completely different or point it somewhere else, and you're able to do that without redeploying any of the users. And you want ability to chain calls with reasonable latency, right? You see these microservice diagrams and they're calls running all over the place. Every microservice is doing something very small, and so you want it to, you're going to need more than one service to do anything of substance. So then you need to be able to chain these calls together and not have it start taking up huge amounts of time. So often these microservices are built around RPC, and so I'll sort of have a little use case here where I've got two services. I'll call them green and blue. This is not about deployment, although I will talk a little bit about deployment later, where you have a Lambda that's calling into a service over here. And what's happening on the left is not really important. Often, the way that these get set up is you have an API gateway backed by Lambda that's, say, calling into DynamoDB. And this is sort of like an assumption that's built into a lot of the frameworks. This is how you're going to set up a microservice. And if you look at this from sort of a, what happens when this call takes place? Well, at first you're making this call, which is calling into API gateway, and there's some overhead. And then that's dispatching the Lambda. There's some overhead in there, and then there's the actual call to DynamoDB. And then coming back out of that, right, The trick is, though, that during this time, this function is not actually doing anything, but it is running. And therefore, it's not idle. Therefore, you're paying for it. And so during this time that the Lambda is running here, you're also paying for this. And at that time, you're paying double. And that's not great. Nobody likes to be charged more than they're using. But if you're making these synchronous invocations, this is sort of what you have to deal with. And so this is, right, Lambdaception, when you have Lambdas calling Lambdas. And if you're async invoking, well, that works great because you aren't double paying, but you also can't get the results back. But if you're synchronously invoking it, you pay at least double. And as I said, in the microservice architecture, you're expecting to be making lots of nested calls. Now, if you have API gateway right at the front, that requires a synchronous invocation, and that's forcing it all the way down. You have to return these results back. If it's something where you're just injecting an event into the system, then sure, you asynchronously invoke, and then you don't have to worry about it. So at iRobot, what we're currently doing is, to get around this, we don't want Lambda calling Lambda. And the reason for this is that we're cost sensitive, right? We sell devices. The customer pays us once, and then we pay the cloud cost for our current functionality for the lifetime of the device, which means that the better our mechanical and electrical engineers do our jobs, the longer our robots last and the more I cost the company. So I'm incentivized to help reduce the costs. So we directly access resources from calling services. And this introduces coupling, right? That if a microservice is using the database inside a different service, even if the code is defined with the service that uses the database, if the schema changes, then you have to update both services. And so we sort of call this microservices in code, but a monolith when deployed. And it sort of looks like this, right? There's an SDK for the blue service that's sitting inside the Lambda, and we stitch that together at deployment time. I've talked about that at previous serverless comps. So what you want, right, is something that looks more like how Node does it. You have two functions that reside in your calling service, and you say, hey, go do something and call me back when you're done. And so that would be ideal, and there are ways that we can get to this, right? You can literally just build that where you're doing asynchronous invocations, but you don't really want to have to build it into your code. You don't want to build all those assumptions in there. And especially if the code over here is saying asynchronously invoke A2, what happens when you want to add another service that interacts with this? Right? It can't do that. So you want some system, right, where when you're passing it in, you're saying, here's my payload, here's where to call me back, right? And again, this is how Node works, right? When you, if you're doing callbacks rather than promises. The trouble here, right, well, so CloudFormation custom resources actually are first of all a great thing. You should use them. And you can back them with Lambdas, right? So you can use CloudFormation to control anything you want, whether it's on AWS or not. And then you have a Lambda that actually runs it. And the way that it works is you get a request into the Lambda that looks like this. And it comes with a pre-signed URL, which are great things as well, where you include credentials in the URL. They're time limited. You heard the Google Cloud folks talk about them earlier as well. And once you're done doing the thing that it's asking you to, you just post the response to that. And then CloudFormation will pick that back up. But this means that you need to know what you have to do at the end. Your function doesn't just get to return a value back to the functions as a service provider and have them do the callback. You need to do that in your code. So to keep the separation of concerns, we want that like dynamic, not in the payload. And it's not clear how exactly IAM policies would get set up in such a world. Do I have to have permissions if I'm calling another Lambda and providing a function to pass it on to? Do I need permissions to give that function name over? And does the called Lambda also need permissions? So I need to have permissions that exist on both sides? Like, these would get complicated, and nobody's really addressed that yet. So what we really need is the ability to chain these async invocations, because as complicated as that might be, it gets more complicated when you want the thing you're calling asynchronously to also be able to chain further down and have it all propagate back up. And so one way to do this would be step functions, logic apps, something like that. For us, looking at step functions, it's tuned right now towards auditability and durability, and to handle something like this, you would need something that runs a little more fast and loose with its state so that it could bring the cost down. And you need state machine tasks, right? I have a state machine in one service, it's calling into something else, that's calling into something else. And here, you can have this where this is just the input and the output of the state machine. I could change what's happening in here, and it's all transparent. And that would allow some of these decoupled logic to happen. But you need to be able to have sort of this handoff between state machines to be able to do that. The entry point, in AWS, this is API Gateway, would have to support these models. So it can't just happen sort of in sort of the back end. It needs to happen all the way through the system. And so it's really a sort of broad support issue, I think. There's also a very different approach you could take, which is that you never pay for idle or for wait. And that would be great. So then when you have that nested invocation, somehow your function would be able to go into an idle mode where it couldn't perform any work, but would also not really consume any resources. That's a pretty major change to the programming model. There are people who I've heard are thinking about this from some startups, and it's a very interesting, different model from how everybody's working today. The next thing is that, when you deploy a set of functions and a set of services, and you're doing that on servers, you get to put them in like a VPC or a subnet of some kind, and you can set up discovery between them. Use console or etcd or something like that. And then you put sort of a boundary around it, and there's a well-known name that you can go and you can look up and say, hey, what's the, where's the user service? And it will tell you something. And you don't have to know which environment you're in. So you can have multiple of these, and they do different things, and they don't need to know that they're in their own little worlds that are different, and just sort of works. And we can't do this today with functions as a service, because they all sort of exist in a global namespace. And so what we want is service discovery as a service. And I think of this as really a missing linchpin, that the ability to, at runtime, change things without redeploying doesn't really exist. And I'd like to see this. This is more of the rest of this is all sort of personal opinion. I'd love to see a key value store that's namespaced by the IAM of the caller. So a lookup that's returning values based on who you are, which we already have to do for all of our functions. So you don't actually, you don't even need to surround these in some sort of container or environment. It would work for, the dinosaurs who are using servers still. And I'd like to note that Azure Service Fabric already has this sort of thing. It has a name lookup inside of it. Azure Functions don't exist inside of that, and Azure Service Fabric is pretty sort of heavy-handed in the way that it sets up its platform. So I think you'd want something a little more modular, but that's sort of a good template for the kind of thing that you might want for this. So coming around to deployment, basically all these platforms offer, a big switch that says, change over. And so you deploy, and, you get to version. On AWS, this is API Gateway stages, Lambda aliases, Lambda versions, right? And you get to sort of switch things over. And it will, do the connection draining, but you don't control the speed of that. You don't get to phase that rollout or say, oh, something bad is happening. Please, let's turn around and not do it. So it's a little white knuckle. You hope it works. And what we want to be able to do, and what traditional microservices on server-based implementations do all the time, is phased rollout. They have canaries, they have A/B testing, right? They have all these fancy things you can do, and that's because you control both the load balancer and everything that's happening behind it. And we don't have access to that in the current functions as a service models. So to illustrate this, I guess, going back to this setup, is that when you're deploying, you want, say, 2 versions of the Lambda, and you want to switch between them, and maybe you're keeping your endpoint the same. But are these 2 different functions, and you're trying to get the gateway to switch between them? Is that easiest for people? Is it easier if they're different versions of the function? Maybe even an alias that makes it transparent? These are things that I'm not sure. We do a system where we're standing up entire copies. Aaron talked about that yesterday. And we're using a separate service discovery service to do our phased rollouts between those different endpoints. And it looks more like this, right? But you can imagine that you can also do that in the path, right? You can switch people over doing routing between the things. Or you can go with different endpoints, right, entirely. And so this is where you'd want the platforms to support better control of how we're actually switching between, so that the client doesn't have to know that they're being switched over, that it's all transparent to them. And if you noticed, right, in this process, there's only one database. And the stateful parts of the system have a different life cycle. You don't want to have to migrate a database for every deployment. That is a painful process. It's an expensive process. And so you want to treat those differently. And it's not just your databases. It's your cryptographic keys. It's your streams that go out to different parts of your application or your organization. It's IAM roles that are assumed by external maybe users, maybe other applications that they have to assume to access pieces of infrastructure that you have. And if you notice here, right, as much as there's 2 different things here, it's still API Gateway, Lambda, DynamoDB. That graph of the infrastructure is not changing. And it changes occasionally. Sometimes you're like, oh, well, I also want some S3 in there. I want to store a copy of the raw information before it's processed. And so that will happen, but the majority of the time you're just updating the code in the functions that exist within that component graph already. And so you need some sort of maybe tiered infrastructure to say, deploy this part, and I'll change that at one cadence, and deploy the component graph, and I'll change that at a different cadence. And then leave that in place and allow me to update just the code inside it, and I'll do that at a different cadence. And they may even be owned by different parts of your organization. So the last thing that I want to move on to is identity and security. And this is important. I'm glad that we have more people talking about it at this conference than I've seen in the previous conferences. People are really starting to grasp that there are new and different issues to address. And I think that that's a very promising trend. And this is going to be more Lambda specific because I'm much less familiar with how the IAM stuff works on other providers. But I assume that it's probably fairly similar. So Lambdas are versioned, which is very helpful, and everything about a Lambda is versioned. And so the role that it uses is versioned along with everything else. But you can't actually key on that version in a policy. You can't say a policy applies to only one version of a Lambda. Which means that if you're changing what a Lambda can do or has to do or is no longer doing, well, you want to keep least permissions, change the policy associated with it. Now, if you want to have both versions existing at the same time, you would need to change the role because the policy isn't keyed on the version, so the only thing you can do is change the role. That's a little weird. You'd rather have that be the policy. But you get into this weird situation where, depending on what's happening, you change the policy at different times. So if I'm adding a permission, when I create that new version, I need to add that permission to the policy so that the new version can operate. But if I'm removing a permission because it's no longer doing something anymore, I can't remove that until I'm done using the old version, which means that your deployment has to understand much more about what's going on inside your application than is desirable. So the other question, and this is something that at iRobot we've struggled with a bit, is how inter-service policies get configured in a dynamically changing environment. Like, where do policies belong? And so if a service exposes an API gateway, well, the callers need to have roles, and they have policies attached to them. So those exist probably in the calling services, but if you expose an event stream, well, there's a binding between the downstream functions that pick up those events. And where does that binding live and the permissions associated with the binding? Does that exist in where the functions live, or is it attached to the stream that they get attached to? And I don't actually have good answers for this. That's something that at iRobot we've struggled with a bit, and we deploy as sort of a third area. We have an application-wide area where we generate our inter-service policies and roles if needed, and our user, like client-facing API gateway. It's a little awkward though, and I think we'd be very interested to see if other people have come up with more sensible solutions. So I'm a little early. I was thinking I was going to be a little over time that we were running behind, but I think I ended early. So serverless and functions as a service are already powerful, right? You've been hearing today and yesterday and at the workshops, right, all of the amazing things that are possible with what providers have out now. And it's easy to get started, and you can also build capable applications, right? And this is great. But at a certain point, you run into roadblocks, either as an advanced user where you want to get into use cases that just aren't quite easy to make manifest, or as a introductory user coming from an application that you can't quite port over in the way that you want. And I think with a few more pieces in place, we can get exponentially better at the applications that we can build. And that's all I've got. And of course, just a note, iRobot is hiring. If you are interested in building the very bleeding edge of serverless applications, come talk to us. Thanks.
When you're talking about the API gateway being async and having all of that,
yep.
Would that basically mean, or what you guys want to have is request comes in, works through the system, and then someone tells the API gateway to keep the request running and then talk back to it? Or?
So I think the question is, would it be more desirable to have API gateway operate in a synchronous context with asynchronous calls happening behind it, or use a more asynchronous mode of communication like WebSockets? I think it depends on the application. Oftentimes, if you control the client, right, building WebSockets may be easier. If you're trying to produce, something that works across a broad range of devices or something, you may want to stick to vanilla HTTP. And so I think both may need to exist. Especially when you get into like an API that you want third parties to use, it may not be feasible to build up, say, oh, hey, you got to sort of deal with WebSockets to come and get our data.
In one line, there's lots of people on Twitter asking why Node is not necessarily right.
No, Node itself is perfectly fine, and I think just the model that Node uses for asynchronous communication or for asynchronous designs is just not necessary to building functions in a functions as a service model. It brings complexity that is not required, that it built up because it was useful to server-based architectures. And for that reason, it's not, it adds complexity that you don't necessarily need. Of course, if you're working with a team who has the experience in that, then of course, like, you're going to be fastest if you do that. It also has the lowest startup times on Lambda. And of course, all the startup times are getting better over time, but I think Node will probably remain out in front, which is, a big bonus.
It was a small font in a very, very long line. Yeah.
Yes.
Single line still.
All right.
Cool. All right. Cool. Well, thank you very much, Ben.